Alright, these notes are going to go into your AP Bio Spiral notebook. We're going to go right next to the diffusion notes that you should already have, and so we're going to put it on the right-hand side page. So the diffusion notes that you already took define some terms associated with diffusion, what it is, and what terms are associated with it. We know that osmosis is specific to water. So on this page, we want to take a closer look at why does water want to diffuse, or why is it that it doesn't want to diffuse in certain situations. All right, so in just a second, I'm going to show you a diagram, but I need you to know what the different colors and symbols on the diagram mean. So a solute is a substance that is dissolved in a solution. Examples of solutes are salt and sugar, and those are the ones that we're going to use in this class for the most part. In the diagram, solute molecules are going to be represented by green dots. So solute is a substance dissolved in a solution. Examples of solutes are salt and sugar. Solute molecules are going to be represented by green dots. A solvent is the dissolving agent of a solution, in this case, water. So water molecules are going to be represented by pink dots. A solvent is the dissolving agent of a solution, in this case, water. Water molecules are going to be represented by pink dots. So water is dissolving the solute. All right, so in my diagram, let's say this represents a tank that is full of water. The tank is divided in half by a semi-permeable membrane. So right down the middle, I've put a semi-permeable membrane. Semi-permeable means that some things are able to go through it, but some things are not. In this case, this particular semi-permeable membrane is going to let water pass through, but not solute. So keeping in mind that water molecules are the pink ones and solute are the green dots. So more soluble, not as many water can move back and forth across the membrane. So, more solute. I said more soluble. More solute. So on this side, I have more solute molecules. So the water molecules have a tendency to be attracted to the solute molecules. And so you can see the pink dots kind of clustering around the green dots. So green is solute, pink is water. There is more solute on the right-hand side. Not as many water molecules can move back and forth across the membrane. The membrane is semi-permeable. That means water can constantly move back and forth across, but the solute cannot. Because there's more solute molecules on this side, more of the water is attracted to the solute, and there's less free water molecules that are able to continually move back and forth across. On the left-hand side, there is less solute, and that means there's more quote-unquote free water. So I have a solute molecule, and the water is still gathering around the solute. It's still attracted to it. But I have tons of water molecules that aren't caught up with a solute molecule. So all of these are constantly moving back and forth across. The net movement of water is from the left to the right then. Because as these water molecules randomly move back and forth across, when they get to this side, oh, hey, there's a whole bunch of solute here, so I'm going to hang out with the solute because they're so much more fun to be around. So then that means they're not going to move back to the left. These guys right here move back and forth across, but when they get over to this side, hey, there's no solute to hang out with, so might as well come back over here, back over here, back. They're going to randomly move. The more solute, the more attracted water molecules are to that solute, and they're going to stay on that side. Water is naturally constantly moving back and forth. But since the right side has more solute, the water moves from the left to the right and ends up staying on the left, from the left to the right, and ends up staying on the right side because it's attracted to the solute. Water is naturally constantly moving back and forth, but since the right side has more solute, the water moves from the left to the right and ends up staying on the right-hand side because it's attracted to the solute. All right, so we already have those two, but we need this bottom part. Water is attracted to the solute molecule, so they stay clustered around the solute molecule and do not pass back and forth through the selectively permeable membrane. Unattached, or free, water molecules move freely back and forth. So when things are diffusing, they're constantly moving. They're usually moving from an area of higher concentration to an area of lower concentration. There is more solute on this side, so there's a lower concentration of water. There's less solute, more water, so there's a higher concentration of water. So the water is moving to where there's a higher concentration of water to where there's a lower concentration of water. And the solute just acts as a place where those water molecules are going to hang out. They're just going to stay there because there's a polarity charge to that.